All right, here's example 7. It's more of the same because what I was doing with you before now, they're asking you to do now. So why is this not switching? There we go. All right, so they want to use end behavior. You got to count the degrees. Degree is 6. So we know it's up, up, unless preceded by negative, and it's not. Um, we're going to sketch this graph using end behavior, x and y intercepts, and zeros of multiplicity. So I'm going to go like this. I'm not the most proficient with this tablet drawing straight lines. That's a little better. And okay, so what do we have here? We have a 0, another 0, another 0. This one is 2, right? This one is positive 1. This one is negative 1, and the multiplicity there is 3. So negative 1, it's got a little chicane. It starts up, so we know it's going to go like that. At 1, it's going to bounce off, so we know there's a little something like that happening there. And at 2, it's crossing through, so we know it's going like that. Now, what about at 0? Well, to figure that out, we're going to go f of 0 is, let's see, negative 2, negative 1 squared, and 1 cubed. That's not important. That's a positive, so we get negative 2. So it's down here 1, 2. That is our 0, our y-intercept. And so how deep does this go? We don't know, but it doesn't matter. We could actually try to guesstimate it. We could pick a point, between 1 and 2. We could do 1.5 and try to figure it out that way. But, I don't really care about that point because the fact of the matter is you don't have enough mathematics yet to figure out where it really is. So, the fact that you got this point correct, this point, that point, and the end behavior, I'm happy. Okay, so this is a good sketch. If you look in your book, let's escape this view and try to like page 43. The actual graph of this problem was, let's see, is that it? Yeah, so right there, we go tools. And let's paste that in here. Whoa, what just happened? And you can compare, oh, you can compare that to what we had. And overall, that's not bad, right? Theirs goes a little deeper, but we put dot 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 there because we weren't actually sure. But their key points are the same. They just added one intermediate, um, like a mid-interval point there to add some accuracy to the graph, but I don't really care about those. Let's look at, do I have example 8 yet on here? Let me look forward. No. So let me bring up example 8. Right, the graph of the polynomial function. This is some guidelines for graphing them. Determine the end behavior, find the y-intercept, find the zeros, using rational zeros theorem, factor and remainder theorems, test for 1 and negative 1, factoring in the quadratic formula, use the y-intercept, all these things to sketch and mid-interval points as needed to sketch a smooth continuous curve. And then we have these additional tools, including the polynomial zeros theorem, complex conjugates theorem, number of turning points, Descartes' rule of signs. Some of these I taught in class, and some of these I left for you to look at on your own if you want them. And then upper and lower bounds, and symmetry. So we have that. We won't have symmetry though unless um, all the all the degrees are odd or all the degrees are even, because if they're not all odd or all even, the symmetry will be neither even nor odd. So moving down, it says sketch this graph. If we're going to sketch it, well, we're going to have to do everything it said. First thing, Actually, let me do a little copy of this, and I'll shrink it down and put it in my notes here. So we're going to determine the end behavior first. Let me throw that up there. Determine the end behavior. And let's go to big view. How do I go to big view? All right. So the end behavior, it's a quartic, but it leads with a negative. So the end behavior is up. Nope, down, down. I'm sorry. It's down, down. Next thing, find the y-intercepts. So we're going to go g of 0 is negative 0 plus 0 minus 0 minus 12. Negative 12. G of 0 is at negative 12. Next thing, find zeros using any combination. So we're going to try to find factors of this. First thing we might want to do is check if 1 is a factor. How do we check if 1 is a factor? We can plug in 1 everywhere, which will just basically have us adding up the coefficients. We go negative 1, negative 4, and that makes negative 17. Clearly doesn't cancel, so that does not equal 0. But what does it equal? Because that's the point we can use to graph later. It equals, let's see, negative 8, I think. Right? Negative 17 plus 9, negative 8. Okay, I'm going to believe myself when I say that. G equals G of negative 1. We switch the signs of the odd degree. There's only one term with an odd degree, so it's going to be 1, 9, positive 4, and negative 12. Negative, negative, negative 13 plus that is 0. So therefore, negative 1 is a factor. If negative 1 is not a factor, I'm sorry, negative 1 is a 0, that means x plus 1 is a factor. And you could do it by long division. We're not going to do that though. We're going to use synthetic division. So I'm going to go negative 1, but notice there's no x cubed here. So let me put in a 0 for the x cubed term, a 9, a negative 4, and a negative 12. And hopefully you're getting good at synthetic division by now. You know to bring down that. Negative 1 times negative 1 is 1, so I write that here. I add that, negative 1, 8, that, 8. I get negative 12. Opposite of 12 is 12. 0. Excellent. It should have a remainder of 0 because this was a factor. Now this right here is negative x cubed plus x squared. What's that? Minus 8x minus 12. Does that factor by grouping? No, I don't think so. Okay, so we're going to have to look for now factors of 12, more factors of 12 that work. Well, let's try 1 just in case. Let's try, see what g at 1 would be. Oh wait, it didn't work before, so it won't work now. Not g at 1. Let's try g at negative 1, just in case there's a multiplicity of 2 on that root. So I'm going to go, that's going to be, it'll switch all the signs, right, that are odd. So that'll be plus 1, plus 8, minus 12. Darn it, no, that don't work. But what does it give me? It gives me 10 minus that is negative 2. It gives me another point that I can use to graph. Let's try the factor 2. To do that, I'll use synthetic division. This is, it's a involved process. You just got to work your way down and try them out one at a time. Negative 1 times 2 is negative 2. Negative 2 that, negative 1. Negative 1 that, negative 2, right? 6 times 2 is 12. Ooh, very nice. Makes a 0, meaning x minus 2 is a root. So far I have this, and now I have that, and I have this right here, which will be constant x squared. So negative x squared minus x plus 6 is that. And does this factor? If it doesn't, we use quadratic formula. If it does, then, oh my goodness, let me pause. All right, so you get this result, and you ask yourself if this is factorable. And it is, you can factor it. I factored it over here. And once you have it all factored, Combining all the factors, you have this. Two factors match. Notice I factored a negative up here so that I'd have x minus 2 again. Multiplicity of 2, using your y-intercept, using your down, down, and all these multiplicities, you get this graph. And review that, read through it slow. Bye.